Bismillahirrahmanirrahim. Assalamu alaikum. Respected teacher, I am Engineer Kamran Khan and my registration number is 18949. And today the title of my presentation is Effect of Natural Aggregates on Different Concrete Properties. Under the umbrella of this title, today I will be going to discuss these further subtitles like what are the concrete aggregates, why we are using aggregates in concrete, what should be the qualities of an ideal aggregate, what are the aggregate physical properties and their impacts on the concrete different properties like the fresh properties and the hardened properties. Now, aggregate is, as you guys know, that concrete is a mixture of cementitious material, aggregates, and water. As a cementitious material, we are either using cement or lime, and as an aggregates, we are using two types of aggregates, such as coarse aggregate and the fine aggregate. As a coarse aggregate, we are using crushed stone, and as a fine aggregate, we are using sand. These two entities, such as aggregates and cementitious material, will be mixed in the presence of water to give us a homogeneous mix, which is known as a concrete. Now, as a general rule of thumb, aggregates occupy around 65 to 80% of the concrete volume. The further demarcation is given in this pie chart. You can see that around 40% of the volume is occupied by gravel, such as the coarse aggregate or crushed. About 25% of the volume is occupied by sand. Around 20% of the volume in concrete is occupied by water, and around 10% of the volume is occupied by cement. And there may be air also present inside the walls of the aggregates, and the volume of which may be around 5%. Now, as you guys know, that aggregates are not having any cementitious properties. Okay, so that's why they are known as inert materials. These inert materials will be mixed with bonding materials such as cement or lime for the manufacturing of either mortar or concrete. Concrete can also be used as aggregates can also be used as a filler in mortar and concrete, and also to reduce their cost. As you guys know, that aggregates are pretty cheaper than the cement. Okay, so in order to reduce the cost, in order to make the concrete economical, and to fill the voids present inside the concrete or mortar, we are using aggregates as a filler. The characteristics of aggregates impact performance of fresh and harder properties. Under the fresh properties, today we will be mostly focusing on the workability of the concrete, and under the hardened properties of concrete, we will be focusing on the concrete strength. Now, why we are using aggregates in concrete? There are few reasons which justify the use of aggregates in concrete. Number first is concrete aggregates provide concrete its compressive strength and bulk to concrete. Okay, it is because of the aggregates that the phenomena of compressive strength is imparted by the concrete, and also it gives us the concrete its main bulk, its main shape. Okay, so that's why we are using aggregates. Second is to reduce the cost of the concrete. As you guys know, the cement is pretty expensive. Cementitious materials are always expensive. So if we will not use the aggregates in the preparation of this concrete, then it will become more costly. because cementitious material are pretty expensive. So to reduce the cost, we are using the aggregates. Then reduce thermal cracking. As you guys know that about 100 kg of ordinary Portland cement produces almost 12 degrees centigrade temperature rise. Okay, so if the whole bulk of concrete or mortar will be prepared with cement, then it will increase the temperature of the mix enormously. So to reduce this temperature rise, we are using aggregates, and which will further reduce the thermal cracking. Then reduce shrinkage in concrete. Okay, so as a rule of thumb, about 10% reduction in aggregate volume can double shrinkage. Okay, like if we are reducing the volume of aggregate in a concrete mix by about 10%, then it will double shrinkage, because cementitious material can shrink more as compared with the aggregates. So reducing a shrinkage, we are basically using the aggregates. Then imparts unit weight to concrete. It is because of the aggregates that concrete is categorized as normal strength concrete, lightweight concrete, heavyweight concrete, and normal weight concrete. Now, what should be the qualities of an ideal aggregate? An ideal aggregate should meet the following requirements. Number one, it should be hard, strong, and durable, so that the resultant concrete will also be hard, strong, and durable. If the aggregates will not be hard, strong, and durable, the resultant concrete will not be hard, strong, and durable. Then it should be non-reactive to cement. The concrete aggregate should not have any reaction with the cement, so that the resultant mixture will be stable and strong. And it should be free from injurious vegetable matter. There should not be any organic matter present inside the aggregate, because they will reduce the compressive strength of concrete. Then the aggregate should not be flaky and elongated, because flaky and elongated particles, they reduce the workability as well as the strength of the concrete. Then concrete aggregate should not contain any material liable to take steel reinforcement. If we are preparing concrete for the reinforced concrete RCC purposes, so okay, so if they will attack on this steel, if let's suppose there will be some impurities present inside the aggregates which will attack the steel, then the resultant RCC will not be stable, and there will be a lot of problems with the reinforced concrete. So these are the few parameters which we must have to keep in mind before selecting a type of aggregate for our concrete mixture. Now let us discuss few physical properties of aggregates. Under the umbrella of this title, I will be going to discuss size of aggregate, gradation, specific gravity, shape, and texture. Under the umbrella of size of aggregate, I will be going to discuss coarse aggregate and fine aggregate. Under gradation, a subtopic, I will discuss uniformly graded aggregates and non-uniform aggregates. Under the specific gravity topic, I will be going to discuss lightweight aggregate, normal weight aggregate, and heavyweight aggregate. Under the shape title, I will be going to discuss round shape aggregates, irregular shape aggregates, angular, elongated, and flaky aggregates. Under the texture topic, I will be going to discuss smooth, rough, crystalline, and porous aggregates. Okay, so now let us discuss or explain this slide further, and the remaining lecture will be focused on the contents of this slide. Now let us discuss the size of aggregate. The size of the aggregate. Based on the size of the aggregate, we are going to subdivide the aggregates into two major categories. Number first is the fine aggregate, and the second is the coarse aggregate. Fine aggregates are those aggregates which are passed from seam number 4, the size of which is 4.75 millimeter. So you can easily say that fine aggregates are those aggregates which are finer than 4.75 mm. And these include your sand and crushed stone. About fine aggregate content usually start from 35 to 45% by mass or volume of total aggregates. Now, what are coarse aggregates? Coarse aggregates are those aggregates which retain on SU number 4 or which are bigger than 4.75 millimeter. They include gravel and crushed stone. Typically between 9.5 mm to 37.5 mm sizes are known as coarse aggregates. Now, effect of size of aggregates on different concrete properties like workability, strength, and economy. Now, surface area. Surface area, as you guys know, that smaller aggregates are having large surface area as compared with the coarse aggregate. Because let's suppose this is a container of a known volume. The volume of this is what? Capital V. This is another container and the volume of which is also capital V. This container number 1 is filled with a coarse aggregate. Like you can see, this container is filled with a coarse aggregate, and this container is filled with a fine aggregate. So in under the same volume capital V, this container will be having less number of aggregates and this container will be having more number of aggregates. So more number of aggregates mean more surfaces. The surfaces are more, then it means that the surface area is more. And in this container, if the number of particles, if the number of aggregates are less, then it means there are less surfaces and the surface area will be less as compared with the container number 2. Container number 2 has got more surface area as compared with the container number 1 having bigger particles. Okay. So now, if the surface area is more, then it means that there will be a need of more cement in order to cover these surfaces. Okay. So if there will be a need of more cement in order to cover these surfaces, then it will create what? Economic problems. Okay, because more need of cement means more need of what? Economy. Also, more water will be required to lubricate each aggregate. Okay, so let's suppose due to a pre-concrete mix design, we cannot increase the amount of moisture content, amount of water content that will be used in the mix. Then the resultant concrete which will be prepared will be like our, as say, partially saturated. Okay, if and let's suppose the aggregates are not properly saturated, then the resultant concrete will be less workable than the large size aggregates. And now what is their effect on the strength of the aggregates? Okay, if we are increasing the size of aggregates, that will severely affect the concrete tensile strength. Okay, on an average, increasing the maximum grain size to about 120 to 180 millimeters, the reduction in tensile strength is about 30 to 50%. Okay, as compared with the concrete which is prepared with the maximum aggregate size which is equal to 20 millimeter. So if we are increasing the size of aggregate beyond 20 millimeter, which is categorized as the maximum aggregate size, then it will reduce the strength of tensile strength of concrete by about 30 to 50%. So that is how size of aggregate is affecting your workability, your strength, and economy. Now, let me discuss gradation of aggregate. Concrete may be well graded, aggregate may be well graded, or they may be poorly graded. Okay, well graded aggregates means the presence of all sizes of aggregates in a particular mixture of aggregate, ranging from fine size aggregates to coarse size aggregates. And poorly graded aggregates means presence of a particular size of aggregate. Okay, that's why poorly graded aggregate is also known as uniform size aggregate, and well graded aggregates are also known as non-uniform aggregates, which are having a range of sizes. There may be another type of aggregates which are known as gap grade aggregates. Okay, which are known as what? Gap grade aggregates, which means the absence of a particular size of aggregates in a particular mixture of aggregates. Now, if the concrete will be well graded, then it means that white spaces are less, because final particles will reach inside the spaces which will be created by the bigger particles. Okay, in poorly graded aggregates will be having less white spaces. Okay, and poorly graded aggregates will be having more white spaces. So if the white spaces are more, then it means more paste will be needed to fill these voids. So by that discussion, I came to know that a well-graded material will be having less white spaces, and the amount of cement paste required will be less. And the poorly graded aggregates will be having larger white spaces, and the amount of cement paste required will be more. So now there will be a compromise between workability and economy. If, for example, I'm selecting coarse aggregates, so I'm selecting well-graded aggregates. So well-graded aggregates will be having a less requirement for the cement paste, but at the same time, they are less workable as well. And, and for example, I'm selecting poorly graded aggregates, which means more white spaces, so more cement paste will be required, and there will be an ingress of more water, which will make the concrete is more workable and less economical. So it is our choice to select more workable concrete or more economical concrete. This is something which will be selected by the contractor or the department which will be using the particular type of aggregate, via well-graded aggregates or poorly graded aggregates. Then aggregate gradation can influence the compressive strength of a concrete. Concrete strength increases when using a dense gradation and increasing fineness modulus of aggregates. So by increasing the fineness modulus of aggregates, it means more surface area will be available for the bond. And if more surface area will be available for the bond, then a good bond will be created, and the resultant concrete will be having a good compressive strength. So this is the effect of gradation on workability, economy, and strength of aggregate. Now let me discuss the specific gravity of aggregate, that how specific gravity is affecting the properties of concrete. There will be, as you guys know, that specific gravity is the ratio of the weight of a given volume of a substance to the weight of equal volume of distilled water. Okay. So any substance which will be having a specific gravity lesser than water will float upon the surface of water, and any substance which will be having a specific gravity greater than water will sink inside the water. Like for example, the usual specific gravity of aggregate lies from 2.65. Around 2.65 is the usual value of the specific gravity of aggregates, which means that the specific gravity is more as compared with the water. So that's why all types of aggregates basically sink inside the water. And on the basis of aggregate specific gravity, we are categorizing aggregates into two categories, like normal weight aggregates, lightweight aggregates, and the heavyweight aggregates. Normal weight aggregates, most common aggregates are sand, gravel, and cruststone. These are categorized as the normal aggregates, and they are producing normal weight aggregates, the unit weight of which will be around 2,200 to 2,400 kilogram per cubic meter. These are the pictures of cruststone, and these are the pictures of sand. Lightweight aggregates, they are shale, clay, slate, and slag. You can see in the pictures, this is a shale aggregate, this is a slate aggregate, and this is a slag aggregate made from melted magma. Now, lightweight aggregate produce structural lightweight concrete, the weight of which will be around 1350 to 1850 kilogram per cubic meter. It will produce lightweight in insulated aggregates, the weight of which will be around 250 to 1450 kilogram per cubic meter. The third category will be the heavyweight aggregate. Under the heavyweight aggregates, the examples are barite, limonite, magnetite, hematite, and iron. This is barite, this is limonite, this is magnetite, this is hematite, and this is iron aggregate. They produces high density concrete up to around 6,400 kilogram per cubic meter, which will be used in radiation shielding for the nuclear power plants. Now let me discuss the aggregate shape. There will be different types of shapes available in the aggregates, like rounded aggregates. You can see this is an example of a rounded aggregates. You can have angular aggregates. You can see there are a lot of angles on the surface of each aggregates. You will be having irregular aggregates, in which you will be having spherical aggregates, angular aggregates. There will be a mixture of each and everything present inside the aggregate mixture. So the resultant aggregate will be known as irregular aggregates. There will be flaky aggregate, and there will be elongated aggregates. Elongated aggregates have more length as compared with the thickness and width. Flaky aggregates have less thickness as compared with the length and the width. Now, rounded aggregates, they are usually found formed by weathering, erosion, and abrasion, and rocks, stones, sand, gravel found in river beds are the usual examples of rounded aggregates. Now, rounded aggregates has got two things. They have good workability because the resistance to flow or sliding is less, but at the same time, they are not having any good interlocking mechanism. So the resultant strength achievable from the rounded aggregates will be less, and the workability will be more. Then the irregular aggregates. Okay, irregular aggregates are also shaped by abrasion, but are not fully rounded up. They consist of small stone and gravel and offer reduced workability. So the workability of the irregular aggregate is small as compared with the rounded aggregate, but at the same time it is more than the angular aggregates because of the presence of some spherical shaped particles. and the resultant strength achieved is improved as compared with the rounded aggregates, but it is poor as compared with the angular aggregates because of the presence of these rounded or spherical particles. Now, angular aggregates, this is an example of a very good type of aggregate because it is having some good interlocking mechanism. However, the workability achieved from such type of aggregate is too low as compared with the rounded and irregular aggregates, but at the same time, it can achieve high strength. So if strength is the criteria, then you can go for the angular aggregate. If workability is the criteria, then kindly go towards the rounded or irregular aggregates. Then flaky aggregates. Flaky aggregates are thin in comparison to length and width. They are having more surface area, so more requirement for cement and water. So under the same amount of moisture content, the workability will be less and the resultant strength achieved will also be less. Elongated particles are longer than they are thick or wide. Also adds more surface area to a mix, meaning more cement paste is required. So less economical, less workable, and less strength will be achieved from the flaky and elongated particles. As a rule of thumb, their value should not increase from 10 to 15%. Now, the last title, which is the texture of aggregate. Under the umbrella of this term, the concrete aggregates may be categorized as smooth or rough. So as you guys know, their smooth surface improves workability. Yet a rougher surface generates a stronger bond between the paste and the aggregates, creating a higher strength. But due to roughness, the workability will be less. So smooth aggregates can have good workability but less strength. Okay, and rough aggregates may be having less workability but more strength. So this is something which I have discussed with you regarding the different properties of aggregates and their resultant impact or effect on the different concrete properties like fresh properties and the hardened properties like workability and the strength. So that was all from my side. I hope this lecture was very useful. I tried my best to explain in a short manner. Thank you so much.